Hello friends, today we will talk about numbers. As you would know, numbers happen to be a wide area which is one of the most favorite topics of the paper setters for any sort of aptitude tests. This topic has a lot of concepts, definitely to keep equal focus on each of those concepts. Numbers will be discussed in multiple modules. So for today's module, we are going to cover concepts on classification of numbers, properties of odd and even numbers, properties of prime composite numbers, and rules for divisibility. So we'll start by understanding classification of numbers. As you would realize, we are talking about wide array of numbers of different categories, starting with real, imaginary, rational, irrational, integers, fractions, and in this chart, I am providing some examples of some types of numbers. In the aptitude tests, which we will target, most likely we are going to face real numbers. Now, we look at integers in terms of natural numbers, prime or composite numbers, whole numbers, odd and even numbers, etc. When it comes to fractions and decimals, we have recurring decimals, we have non-recurring decimals. We are also talking about proper fractions. These are some of the types of fractions and decimals. So if I summarize, this diagram will represent the family of numbers of different types. If I look at properties of odd and even numbers, this table will demonstrate the properties in terms of addition, subtraction, and multiplication of a pair of numbers where one number is even, the other number is odd, or both are even, or both are odd. So some examples are there. You can understand the properties very well with those examples. We will look at some rules for divisibility. Now this table will demonstrate some typical rules for divisibility by 2 up to 10. For example, you can see if I have to check whether a number is divisible by 3, I have to sum up the digits. If the addition of the digits is divisible by 3, then we will say that number will also be divisible by 3. So that way we have rule for all these numbers. For example, if I have to check for divisibility by 8, we have to check for the number found by last 3 digits. There is a special rule, however, for divisibility by 11. Let us understand that rule. What we have to do in this case is to add the numbers in odd places and even places. If I add the digits in even places and odd places, and I check the difference of the sum, if that difference happens to be 0 or a multiple of 11, then we will say that that entire number will be divisible by 11. So we are going to look at some questions. All right, this is the first question where it says average of 4 prime numbers is 12.25. So they're asking which prime number must be one of those. Now let us understand, let's see how we can tackle this question with a very fundamental concept of numbers which we already know by now. So if I list down these prime numbers, I will call them P1, P2, P3 and P4, let's say. But even before doing that, let us understand one thing. If the average of 4 numbers is 12.25, the sum of these numbers will be 49. Now, when I list down these 4 numbers, on the left hand side, we are talking about addition of 4 prime numbers. On the right hand side, we have 49. We know usually prime numbers are odd. For example, you can think of numbers like 3, 5, 7, 11, etc. But then when we add 4 odd numbers, By the property that we just discussed, we know that addition of four odd numbers is supposed to be even. But you see on the right hand side, we have an odd number, which is 49, which means our assumption was not correct. Now, what assumption did we make? We assumed that all these four numbers are odd. So that assumption was incorrect, which means one of these prime numbers must be even. And what is the only even prime number? The only even prime number is 2, right? So our answer to this question is C, will be number 2. Hope that was clear. So we'll move on to the next one. Now here is question number 2, where it talks about a recurring decimal. All right. So at the end, they're asking which of the following numbers necessarily produces an integer when multiplied by D, right? So let's understand this question, guys. So at first, if I multiply D by 100, what we will get is A1, A2 decimal, A1, A2, A1, A2, etc. When I subtract 100D minus D, interestingly, what happens is all these digits after the decimal point will get cancelled, and as a result, what I'll get is 99D is equal to A1, A2. So the value of D will be A1, A2 by 99. In the chart that I showed you for classification of numbers, you have realized that recurring numbers are one type of rational numbers, which means any rational number can be expressed in the form of P by Q, where P and Q are whole numbers and Q is not equal to 0. So you see D is being able to express, we are being able to express D as P by Q, where in the numerator and denominator we have whole numbers and the denominator is not equal to 0. So this method is called rationalization of recurring decimals. Just for your knowledge, I share that. Moving on with the sum, where they have said the multiplier should be such that the product will give me an integer, which means P must be able to cancel 99 in the denominator. So in the denominator of D, we have 99 that must get cancelled. Only then it will produce an integer value, right? So the choice becomes very easy from the options. Option 4 is 198, which is definitely a multiple of 99. So that is your answer. Hope that was clear. So we'll move on to question number 3, where it talks about sum of page numbers of consecutive sheets of a book. They're asking whether that number will be even or odd. Let's understand this, guys. You see, in a sheet of paper, in a sheet of book, we have 2 page numbers. On one side, we are talking about an even number. On the other side, we have an odd number, right? So essentially, when I add all these numbers in these 25 sheets, we are talking about adding 25 pairs of numbers, out of which we'll have 25 even numbers and we will have 25 odd numbers. Definitely the summation of 25 even numbers will be even, and the summation of 25 odd numbers will be odd. You see, when I add 3 odd numbers, the result is odd. When I add 5 odd numbers, the result is odd, and so on. That way I can conclude the addition of 25 odd numbers must be odd. So essentially, we are talking about adding an even number and an odd number. Definitely the result has to be odd. So your answer will be option 2, which is odd. I hope that was clear, guys. We'll move on to question number 4 now. So given this expression, they're asking what should be the value of n such that this expression becomes a perfect square. Let's understand this. You see, a square plus 2ab plus b square happens to be a plus b whole square. So if I look at this expression, I'm just changing the positions in the way which is favorable to us. I'm writing this as 2 to the power 12 to begin with, then 2 to the power 15, and then 2 to the power n. So definitely we will try to draw an analogy with the expression a square plus 2ab plus b square. Let's see how it goes. Definitely 2 to the power 12 can be written as 2 to the power 6 whole square. So in that case, A becomes 2 to the power 6, Then if I look at 2 into A into B, that will become 2 into 2 to the power 6. And now why have I written 2 to the power 8? Because I want to match the power 2 to the power 15. So if you look at the powers, 1 plus 6 plus 8 becomes 15. That way, B happens to be 2 to the power 8, all right? So B square will be 2 to the power 8 whole square. And hence, we can write this expression as 2 to the power 6 plus 2 to the power 8 whole square, which becomes analogical to A plus B whole square. Hence, it becomes a perfect square. So obviously, to make it a perfect square, the value of n has to be 16. So your answer is option 2, which is 16. Okay, we'll move to question number 5 now. So given a 5-digit number, that is KLM35, they're asking whether it's a perfect square. Now let's learn something very interesting about perfect square of a number that has a unique digit of 5. You see, what we do is to take the digit except 5, which is 3 out here. For 35, I am taking 3. And then we consider the number right after 3, which is 4. And then we multiply 3 into 4, that gives me 12. Right? And the other part, of course, becomes 5 square. In the unit digit of 35, I have 5. So I just take 5 square, which is 25. I put it after 12. So that becomes my answer. So you see 35 whole square becomes 1225. Interesting, right? So you see the logic over here that we can apply is, if KLM35 has to be a perfect square, then the square root must have 5 in the units place. Right? But then by the virtue of the rule that we just learned, we can say if the base value has 5 in the units place, then for the square, the last 2 digits must be 2 and 5. So the last 2 digits of a perfect square can never be 3 and 5, which is the case here. So we will say always no. If the question is the 5-digit number KLM35 a perfect square, my answer will be always no. All right, guys. I hope that was clear. So we'll move on to the next one. Let's understand this. So given these many numbers, one after the other, we are supposed to decide whether these numbers are divisible by 132. And we will check those things by applying the rules for divisibility. Let's understand one thing. 132 can be broken into 3 into 4 into 11. Now, why are we doing that? We will do this because 132 is a composite number. To check for divisibility by 132, we must break 132 in the form of co-prime numbers. Now, co-prime numbers imply numbers where a pair of such numbers will have no common factor except 1. Right? Now we are going to check for divisibility by 3, 4 and 11, and hence we will conclude whether this number is divisible by 132. No doubt that 264 is divisible by all these 3, 3, 4 and 11. Hence 264 will be divisible by 132. Moving on with 396, same logic will apply. So we can see that 396 will also be divisible by 132. Moving with the next one. Now in this case, you see, if I look at 62, the last 2 digits of this number is 62, that is 62. And we know that 62 is not divisible by 4. And hence we will say that 462 is not divisible by 4. And hence 462 cannot be divisible by 132. You see, if a number has to be divisible by 132, it has to be divisible by each of these 3, that is 3, 4 and 11. Moving on with the next one, of course, 792 is divisible by 3, 4 and 11. We can check by applying the divisibility rules. Very quickly, let's understand. For 3, we will sum up the digits. So 7 plus 9 plus 2 gives me 18. That is the sum of the digits. Since 18 is divisible by 3, we can say this 792 is divisible by 3. If I look at 4, the last 2 digits gives me 92. 92 is divisible by 4, and hence the number will be divisible by 4. If I take the case of 11, you see alternate digits are 7 and 2. When you add it, you get 9. The middle digit is also 9. The difference is 0. Hence, we can say that this number will be divisible by 11 also, right? Hence, 792 is divisible by 132. Carrying on to the next, now in this case, if you sum up the digits for 968, you see 9 plus 6 is 15, 15 plus 8 is 23. 23 is not divisible by 3, hence this number will not be divisible by 3. Hence we can conclude that this number will not be divisible by 132. Moving on with 2178. Again, if I look at 78, the last two digits, it is not divisible by 4, hence it will not be divisible by 132. Similar logic will apply for 5184. If I take the alternate digits this time, I see that the difference does not give me 0 or a multiple of 11. In fact, you see on one side 5 plus 8 is 13. On the other side, 1 plus 4 is 5. The difference between 13 and 5 is 8, which does not give me a situation where I can say it would be divisible by 11. Hence, this number cannot be divisible by 132. Moving on with 6336, of course, it goes by all these 3, 3, 4, and 11. Hence, it will go by 132. So out of all these numbers, you see we have listed down 4 numbers we can see which are divisible by 132. Hence, our answer to this question will be option number 1, which is 4. All right, guys. I hope that was clear. So we'll move on to the next one. So here they're talking about 9-digit numbers, which will be having 1 to 9, right? All these digits. So if I take example of some of these numbers, you see the digits will change their positions, but at the end of the day, we can conclude for any such numbers, if I sum of the digits, if I add the digits, I will always get running sum from 1 to 9, which is 45. And since 45 is a multiple of 9, we can definitely conclude all these numbers will be multiple of 9. And hence we can say all these numbers will be composite numbers. Hence none of these numbers will be prime, right? So it was a tricky question. Your answer will be 0 because none of these numbers will be prime. I hope that was clear. So we'll move on to the next one. So here they're talking about a 3-digit number and its reverse. Let us understand. We will check the options. We will try to verify. So I'm taking an example of a 3-digit number where C is the unit digit, B is the tens digit, and A is the hundreds digit. The value of this number will be 100A plus 10B plus C. When I reverse this number, it becomes CBA, value becomes 100C plus 10B plus A. Now, when I add these two numbers, what I get is 101 times of A plus C plus 20B. So if I check the options, if I take the first option, you see after adding 2B, that is 2 times of middle digit, what I get does not go by 11. Hence, first option cannot be my answer. In fact, if I just look at third option, when I add 20 times of rather I'm subtracting 20 times of A, what I get does not go by 81, which means option 3 cannot be my answer. Now, interestingly, if I go by option 2, you see while I add 81 times of B, what I will get will give me an expression which will be divisible by 101. Hence, the correct choice that we should mark will be option number 2. All right, I hope that was clear, guys. So we'll move on to the next one. All right, interesting question. You see, they are saying that one leaf has been removed from this book, and as a result, the sum becomes 1 to 28. Now let's understand something very conceptual. We know that for a novel, if it has n number of pages, so the last page number, let's say, is n. So the sum of all these page numbers would have been 1 plus 2 up to n. That is running sum of n. And we know that the sum of n natural numbers is n into n plus 1 by 2. So what it says is, if I look at this particular page which is being removed for this leaf, there will be two numbers. On one side, we are talking about page number K, and the next side we'll have page number K plus 1. So when I subtract this, after removal of this leaf, of course, what I will subtract will be summation of K plus 1. As a result, we should get 1228, which is given in the sum. So let us understand, what if I take 49 to be the case? So the sum of these page numbers will become 1225. Now you see, after removal of that leaf, some number will be subtracted, and as a result, we are expected to get 1228, which is impossible, right? Because 1225 is already lesser than 1228. Hence, this is not going to be my answer. So if 49 is eliminated from the choices, going by the same logic, we should eliminate 42 as well, because 42 is lesser than 49. So let's take next case, which is 50. If I add the page numbers, what I'll get is 1775. After removal of this leaf, what I'll get is 1228. So of course, what I'm removing in terms of a number will be 47, which can be expressed as a sum of two consecutive numbers, that is 23 and 24. So I can see that the page numbers of that leaf on both the sides were page number 23 and page number 24 respectively. Hence, this gives me a feasible case, right? In fact, just to check with 51, you see the summation will become 1326. So after removal of this leaf, it becomes 1228. Hence, this number becomes 98, which is not possible because it cannot express 98 as a sum of two consecutive numbers. It's an even number. All right. So 51 will also be eliminated. Hence, we go back to the choice that we already made, that is 50, which will be our answer. I hope that was clear. So we'll move to the next one. All right, this is question number 10. So we are expected to find a number given some properties that they have said. So let us look at this number quickly. So if I assume the original number to be n1 and n2 happens to be the number obtained by reversing its digit, what they have said is 32 times of n1 will be equal to 23 times of n2. Now you see, very interestingly, 23 and 32, these two numbers are co-prime, they're mutually prime, that is prime to each other. There is no common factor. And hence, we can always conclude that n1 will take values which are in multiples of 23 and n2 will take values which will be in multiples of 32. So the choice becomes very simple from the options. See, it cannot be insufficient information because the data is sufficient. In fact, if I use the other information that I have not used so far, definitely I will get an answer. So out of the choices, we will mark that option which becomes a multiple of 23. Hence, our answer has to be option number 2, that is 69, because that is multiple of 23. That is my number. In fact, if you have noticed, we have not even used one part of the information. I hope that is clear. So we'll move on to the next one. Another interesting question. So they have said product of 14 integers is 1. So let's understand what could be the cases over here. So we can look at one case where all the numbers are plus ones. Definitely the products will be integer and the product will be 1 definitely. If I look at case 2, what we can have is all the values are minus 1. Definitely the product of 14 minus 1s will be plus 1 only. The other thing that we can have is some of the values will be plus 1 and the other values will be minus 1. But one thing that we have to keep in mind in that case, the number of minus 1s must be an even number. You see, only then that portion will give me a product of plus 1. Now, in this case, they have said which cannot be the sum of these integers, which means we have to eliminate the possible choices. So we have to take the choice, we have to mark that option where the number is impossible. You see, if I take the first option, Definitely 14 is a possibility. If I have 14 into plus 1s, this will give me 14. What if I have 10 as the sum of these integers? Is it possible? Yes, of course. If I have 12 plus 1s and 2 minus 1s, this result will be 10. Is 6 possible? Let's understand. Yes, of course. If I have 10 plus 1s and 4 minus 1s, that will result in 6. Is 0 a possibility? Now you see, if 0 has to be a possibility, then the situation should be 7 plus 1s and 7 minus 1. But how is that possible? Because we have to have even number of minus 1s, right? Which is not getting satisfied. Hence, this is not possible. So here they have said which cannot be the sum of these integers. So our answer choice will be 0. That is option 4. All right. I hope that was clear, guys. So we'll move to the next one. This is question number 2, where they have said, talking about first 8 natural numbers. Right. Let's understand this. If I add 8 natural numbers, the summation is 36. Now the question is, I have to place a minus sign by changing the plus sign. If I do that, what I get is 26. You see, if plus 5 is changed to minus 5, then it will reduce by 10. In fact, I could have done that by writing, minus 1 and minus 4 also. So I have just checked whether it is possible or not. So my conclusion is yes, of course it is possible. All right. So we'll move on to the next one. So in this case, they have said what needs to be multiplied to make it a perfect square. Let's understand this. You see, in this expression, we already have a few perfect squares. Let's identify 16 happens to be a perfect square. Of course, 9 is a perfect square. And then if I look at these pairs of 2's, that gives me a perfect square as well. And definitely 4 is a perfect square. So what stops it from being a perfect square? Definitely 11 and 6 is there, who do not have a pair, which is why it is not becoming a perfect square. Hence, to make it a perfect square, you see, we must have a situation where I must be having one more 11 and one more 6, so that a pair of 11 and a pair of 6 will make it a perfect square. So the number that needs to be multiplied should be 11 into 6, which is 66. So my answer is 66. All right. So we'll move on to the next one. Now let's take this. We have a series of 9s. In fact, we have 2000 9s over here. They're asking us to find out the sum of the digits of n square. Let's look at some interesting pattern of numbers. You see, if I look at 9, the square is 81, and the sum of the digits is 8 plus 1, 9. Now when it becomes 99, the square is 9801. And then the sum of the digits is 9 plus 8 plus 0 plus 1, which is 18, which is 9 into 2. Now 999 square is 998001. Very interesting, you see. If I compare with 9801, which was square of 99, what you do is in the beginning you add a 9, and in the middle, in between 8 and 1, you add a 0. That gives you the square of 999. However, the sum of the digits, as you can see, is 27, which is 9 into 3. So if I that way look at 4 9s, the square happens to be 999, which again follows that pattern of adding a 9 in the beginning, adding a 0 at the middle. Summation of these digits is 36, which is 9 into 4. So if I follow this pattern between n and the sum of the digits of n square, I see that sum of the digits of n square represents n into the number of times I have, 9 into the number of times I have 9 in n. For example, in 99 we have two nines and sum of digit of n square is 9 into 2. In 999 we have three nines and the sum of digit of n square is 9 into 3, and so on. So of course in this case, if I am talking about 2009s, n square will have a sum of the digit which will be 9 times of 2000, right? Which means my answer will be 18,000. All right, I hope that was clear. So we'll move on to the next one. Now this is an interesting question. You see, they are talking about a large number which has been formed by writing natural numbers starting from 1, 2, 3, 4, and so on. And they have ended by writing 50 such natural numbers one after the other. The last portion becomes 48, 49, and 50. So that becomes a large number. The question is, what will be the remainder when n is divisible by 32? And something very interesting, as a fact, I have shown you at the bottom. You see, there is a similarity between remainder rules and divisibility rules, right? That as a concept you should know. In fact, we will also bring this up in the session for remainders. All right, now let us look at the solution for this. You see, I will show you a pattern at first. If I have to check for divisibility by 2, which is 2 to the power 1, we check the last one digit, right? Similarly, if I have to check for divisibility by 4, which happens to be 2 square, we have to check for last two digits. In case I have to look at divisibility by 8, which happens to be 2 cube, we need to check last three digits. If I have to that way check divisibility by number 32, which is 2 to the power 5, I will check last 5 digits. So given this number, what are the last 5 digits? Of course, that's 84950. Then all you have to do is to manually divide 84950 by 32, and as a result, you will find 22 as a remainder. All right. So the answer to this question will be 22, which is option 2. Okay, a very conceptual question from understanding divisibility rules. Moving on to the next sum. So there are a lot of such situations where the paper setters will try to divert your attention by giving a unnecessary set of information like a story. You see, you should be able to filter out the most important part, which is why I have marked those, right? So all that matters over here is to check whether 5A196B, this number is divisible by 108. Now, how do I check that? You see, 108 can be written as 4 into 27, where 4 and 27 are co-prime. That is exactly why I have written as 4 into 27. Which means the logic is this number 5A196B should be divisible by both 4 and 27. So if I have to check for 4, I have to check for the number formed by last two digits, which is 6B. For 27, we should be understanding that 3 and 9 are factors of 27. So we should have a situation where this number is of course divisible by 3 and 9. And we know for either 3 or 9, we should look at the sum of the digits. Now let us also understand another thing that they have said over here is that the difference between A and B is 1. So let us list down the values. You see, if 6B has to be divisible by 4, then the possible values of B could be either 0, that will give me 60, or 4, that will give me 64, or 8, which will give me 68. Now from this a piece of information that the difference of A and B is 1, I have listed down possible values of A corresponding to the values of B. And also I have written the sum of digits corresponding to those pair of values of A and B. Now for each of these cases, I'm trying to understand whether the sum of digit is a multiple of 9 or not. And I get only one case where it is a multiple of 9. So all other cases are eliminated. So the only possibility that will create a situation where it could be divisible by 4 and 27 is that the value of A has to be 7. So our answer to this question will be option 1, that's 7. I hope that was clear, guys. All right, we'll move to the next one. Again, you see another situation where they try to, you know, divert your attention, unnecessary information. So all that matters is how quickly you can filter out the most essential part from the sum, which is what I have highlighted over here. So we will try to solve it by understanding what is being said out here. You see, they have said that for this number, we will have a prefix and a suffix. And we are supposed to check whether this number is divisible by 11 and 8. Now we know that for divisibility rule of 8, we have to check for last 3 digits. So the number found by last 3 digits must be divisible by 8. Only then the entire number will be divisible by 8. What if I take the first option, which is 3, 7? So in that case, the suffix will be 7. So the question is 457 divisible by 8? No, it is not. So we will eliminate the first option. What if I take the second one? Yes, 456 goes by 8. In fact, that will be my answer. Just to practice, we will look at why the other two are not my answer. You see, 454 is not divisible by 8. Neither is 452. Hence, option 3 and option 4 will also get eliminated, right? So we are back to our answer. That is option number 2. You see, we did not even have to bother about divisibility by 11. So we could save a little bit of time, right? Moving on with the next one. Now in this case, we are talking about a 5-digit number. So you see the largest number where the summation of digits will be 5 has to start with 5 and all other digits can be minimized, that's zeros. For smallest number, the leftmost number must be 1. You see the leftmost number cannot be 0, otherwise it will not remain a significant 5-digit number. After putting 1 in the leftmost place, you can put all zeros unless you get the unit digit, until you get the unit digit where you put 4, so that 1 plus 4 becomes 5. So of course, you can make out the difference. That is 3,996, right? So your answer is there, option number 2. Moving on to the next one. So we have a typical situation where they're talking about place values, that is hundreds digit of A and B. So let's understand. If I look at A and B, you see the units place of A will be summation of 1 to 9, which is 45. So if I have 5 in the units place for A and 4 goes as a carry, then we are talking about summation of 1 to 8, which will be 36. And then if I add that 4, I will get 40. So 0 comes over here and 4 goes up in the carry. And then 1 to 7 will be 28, plus that 4 will give me 32. So 2 comes down and 3 goes up in the carry. So we can say that the hundreds digit of A will be 2. In the same way for B also, you see all 9 ones will give me 9 in the units place. All 8 twos will give me 6 in the units place. And then we have 2 in the hundreds digit of B. So of course the difference will be 0. So your answer to this question is 0. I hope that was clear. All right, so we'll move to the next one. Now, very interesting question in front of us. You see, we are talking about a large number that looks like a power of 100. Of course, we know it means multiplying 100 to itself x times. Now, what happens if I do that? Don't we get a number that result in something where there will be a lot of zeros at the end? Now you see, for a number like 1000, it is perfectly divisible by 8. So we can definitely say that the remainder will be 0 if I divide 1000 by 8. So in that case, we can say if I divide r by 8, since r had so many zeros at the end, the remainder will be 0 because it will be perfectly divisible by 8. Alright, so our answer will be 0. So that is all for this particular module for numbers. We will look at some more concepts on numbers in the next module. I hope all these were clear to you, and I'm sure if you go through this video carefully and if you note down the useful information, it will benefit you a lot for competitive exams. That's all for the day. Thank you so very much. Thank you. Bye-bye.